So that's the equation of a line. Now, what kind of other problems can we get? Well, one thing that we are often talking about with equations of lines is this idea of a parameter. So this lambda value, this is actually what we call a parameter in the sense that it can actually be any kind of value, and it's changing the x, y, z values. So when we learned about parametric equations in year 11, one thing that they talked about afterwards was talking about these Cartesian equations. And Cartesian equations, they're in terms of x, y, and z. So I guess the question is, how do you go from this sort of parameterized form to Cartesian equations? So we can look at that kind of question. And here's another one for you. Let's go over here. Let's take this guy. So we've got these 2 points now. We've got EG2. A is -215. B6. Yeah, 4. We know how to find the equations of lines. That's a pretty standard thing we can do now. So the idea is we want to find a direction and then choose any one of the points, right? So, I mean, let's go ahead and do that. Angus, tell me out for A. What do I need for the direction? Yep, so that's A to B. So we want a vector equation of a line. Yeah, so B minus A. Good. And so that's going to be 6, 3, minus 4. I shouldn't always do them in column notation. You can get them in all sorts of forms, like component form as well, that they like to use a lot. So minus -2, minus 1, and minus 5. Okay, cool. That looks better. So that's 8 to -9. So we get?
Yes, sir.
Yep. Okay, so that's our direction vector. Equation of a line, though, we need that point as well. And I mean, I always just choose the first one. I don't have to really think about it. So equation of a line is, now they write it, I want to write it like this, and I'll show you why. So we go, let's choose a point, let's choose -215 plus lambda 8 to -9, right? Yeah, so a parametric equation is basically something written in terms of a variable, like a hidden variable. Yeah, like t or theta they often use. So in this case, we've got lambda, right? So probably all we have to do is express these x, y, z values in terms of lambda. And actually, you've got them here already. Because if you think about it, these all correspond to particular x, y, and z values, right? For example, here, x, what's x equal to? Well, what are the corresponding x values here? That would be -2 plus 8 lambda, or lambda 8. Let's go. What did I write? All right, 8 lambda, lambda 8. Let's go 8 lambda. Yeah, it's like a variable, right? Yeah, 8 lambda. So okay, so that's our x value in terms of this hidden variable lambda here. Right? So we can do the y's as well. So just 1 plus 2 lambda, and z is 5 minus 9 lambda. Now that's just another way of writing it, but what that allows you to do now is actually determine much more easily if particular points lie on a line, right? Because if particular points lie on a line, as we said, like we can actually change the value for lambda so that, let's see, we can change the value for lambda so that we get different points along this line. How could we determine if a particular point lies on the line or not, though? That's the question. So when they say Cartesian, they like eliminate the variable, essentially. And parametric is in terms of the variable. But how do we determine if a point lies on the line? Like think back to 2D, how did we determine if a particular point lied on the line or not? We had to substitute something in and see if it's satisfied, right? So for example, this one, what are we substituting, what are we trying to satisfy though is the question. Because like with 2D ones, y equals to mx plus c, you had all your variables and essentially you're putting in x and y and seeing whether that equation was true, right? But you don't have a lambda value here, right? You only have x, y, z values. Do we?
Yeah, I just. We have it done.
Well, so the reason why we don't have a lambda.
What does lambda, like, what's it doing?
Lambda's any, because remember with the one that you were looking at, with the perpendicular one, you could have like 1, 3, 5. But they can just easily have 2, 6, 10, right?
So it's just like,
It's scaling it, right? That's what the direction vector is doing, because you're adding these vectors along, and then the longer they are, the further.
just let lambda equal anything.
Okay, that's what we can do. And in fact, we do it the other way though. Because lambda can be anything, what we do is we substitute in these x, y, z values, and you're going to solve for lambda, but something has to be true for these when you substitute them in. It has to be the same, because this is a constant that's being multiplied with this whole vector. It's a scalar, right? So you can't just say, oh, lambda is 5 for these two, but then like 2 for this one, right? That wouldn't make sense. Yeah, so let's substitute them in and make sure they work. So this is part C now. So we've got negative 10 equals to minus 2 plus 8 lambda.
Lambda.
We've got negative 1 equals to 1 plus 2 lambda.
Lambda.
And we've got 14 is equal to 5 minus 9. All right, lambda, what do we get? Can you give me some lambda values, people? Where are the lambda values? Where are the lambda?
-1 plus and -1.
Yeah. Yeah, Matt, next one.
-1.
Oh, hang on. We're on a roll here, boys.
Wait, is that true? Oh, it's -1. I just guessed. I'm sure. Yeah.
And this one is negative 1. Okay, so all the lambda values work. So therefore, 10, negative 1, 14 lies on the line. Let's try the other one. So we've got, and that was the worst written line I've ever written. Okay, so then the other point is for D 38, 11, 50. Same thing, right? So we're creating these equations. We want to see if the lambda value is consistent. So we've got 38 is equal to minus 2 plus 8 lambda. Y is equal to 1 plus 2 lambda. And Z, oh wait, sorry, I didn't put the values. 11 and then 50 is equal to 5 minus 9 lambda.
Wait, so -1? Okay.
Let's do that, man. Don't care.
Lies on the line.
So remember, we need to solve these and check whether lambda's consistently the same.
Lambda. Made it.
I don't know. You find that out for me.
Isn't it a Greek letter?
It is, I believe so. Greeks did a lot of things.
They think they're good.
Check exists.
Like ancient Greeks.
T-shirt.
Greeks people still exist.
I don't believe they.
They're all a myth.
So if we add 2, what's 40 divided by 8? That's a solid 5.
Yeah, 5 arenas. We're looking good.
And we're going to get 11 equals to 1 plus 2 lambda. Then we're going to do that's 5.
So sick.
Wait a minute.
And here we go.
50 equals to 5 minus 9 lambda. We got to be 45 divided by 9 minus 5.
What's going on there?
Wait, what?
50 minus 5.
Yeah, it is minus 5.
Oh, minus 5. Okay, yeah, so that's not right.
Oh, did I just trick you? Did I try and bait you? So what is it? -5.
It is -5.
So-
You said lambda equals lambda. What are you doing?
Okay, that was a typo. So just be careful. They may try and trick you with something like that. Like you think, oh yeah, they're all going to be the same. They look like they're going to be the same, and then they just throw one of these whirly ones at you. So that's how we can check whether it lies on the line. We have to substitute them into the parametric equations and see if we get a consistent value for lambda. Okay, so vector equations line.